Okay, hello everyone. Welcome to this live stream. Okay, just want to make sure the audio is coming through. Okay, so in this live stream, we're going to continue with this tank game asset. Once again, my name is Jonathan Gonzalez. I am going to be looking at chat from time to time. So if you have any questions on anything that we're covering here in this live stream, within this live stream, or really anything related to game development, even some Blender, I'll do my best to answer questions. But with this live stream, we're going to continue with this tank game asset. In the last live stream, I didn't really get to cover a whole lot, but I will be going over what I did cover in that stream. Hopefully this stream doesn't drop out like that one. But today we're going to be mostly covering the tank turret, and we're going to be rotating the turret. So as I move my mouse left and right, I want the turret to actually rotate with it, but we're also going to introduce a delay with that. So along with that, that's just part of the mechanic for rotating the turret. I also want to be able to actually fire. That is one of the main reasons of having a tank, having this huge turret right here. So this barrel is going to go in and out. We're going to be doing this through a script, or rather through visual scripting. Once again, I am using the Bolt visual scripting system for this. But basically, whenever I left click, I want this to go in and come back out. And it's going to happen very, very quickly. But along with that, after we're done with that, I also want to actually fire out a projectile. So this projectile is going to fire out once this moves back. Sorry. So that's what we're going to be covering mostly for today. I am going to allocate about 2 hours for this. So I'm going to try to combine all that stuff within the 2-hour time frame. Before we take a look at the turret and the movement of the barrel, what I want to do is I want to go over what we covered in the last stream, and then we'll continue from there. So if I just quickly play this, I can move forward and backward. I can also now turn in place. Now the turning is probably a little bit too quick. I can reduce the speed at which we turn because I don't want him rotating that quickly. But you can see if I move left or right, the tank treads also move. And let's see if I go into a scene view. You should also see that the gears also rotate forward as well. Okay, so we have some basic movement for the tank, moving forward, backward, turning, all that kind of fun stuff. So let's take a look at the visual scripting that I modified to include that turning rotation for the tank. So I'm going to go back to my tank, and we have a number of variables in here. Let's see, I went underneath the tank controller. That's where I added it in. And I'm going to move my windows around to give us a bit more room to work with in here. Okay, so for the tank controller, we basically just have two different things in here. We have one that controls the, let me go in full screen here. We have one that controls the movement of the tank forward and backward. And then we also have one down here that is controlling the rotation of the tank. Both of these are based off fixed update, which updates at a fixed rate of say 0.02 seconds. So with this, we're using the horizontal and the vertical axis. Vertical axis controls the forward and backward movements. And then the horizontal axis is used for the turning. So that's the X axis. And that's the A and D keys on my keyboard, or the left and right arrow keys. If you are using a joystick, these would also work with that as well. But more specifically, I'm looking at the rotation. So what I'm doing here is I'm taking the horizontal input axis. If I press the right arrow key, we're going to go between 0 all the way up to 1. And it's going to happen very, very quickly with a keyboard. If I was using a joystick, we could actually go between 0 and 1 to say 0.25 or 0.5. But we're taking that value and we're multiplying it by a turning speed variable. This allows us to really amp up that value so we can go very, very quickly. Now, I then multiply that by time delta time. This allows us to make this frame rate independent. It's based off time and not a frame rate. I then take that information and I use something called a quaternion Euler. This allows me to specify that I only want to rotate along the y-axis. In Unity, the y-axis is up and down. I don't want to rotate along the x-axis or the z-axis, so those are left at 0. So the only thing I'm modifying here is the y-axis of the tank. Finally, we're just calculating values here for what we want to rotate. I need to actually apply that rotation to the rigid body. So the tank has a rigid body. I want to get the rotation of that rigid body and multiply it by whatever value that we get here. And then I want to set the rotation by using move rotation. So move rotation then takes the output of this multiply node and that allows us to actually rotate the tank left or right along the y-axis. Okay, so that's all we did for the tank rotation. So now we have the basic movement of the tank forward and backward and also turning. The other thing that we left off with in the last stream, which was hiding the cursor. So let me jump out of full screen and I'll demonstrate this again. So whenever you're playing a game like this, you always want to ensure that the cursor, which is the arrow here, is hidden. Because in a game like this, I would probably have a crosshair in the middle. I do have one in here, and we'll probably take a look at that later on. But the crosshair in the middle is going to be obstructed if we have the arrow in front of it as well. So I want to hide this cursor, but I also want to ensure that it's locked to the center of the screen. So jumping back into my game view, if the cursor starts off up here when I play my game, that is now the pivot point for when I rotate the camera around. So if I move left, I now have to move a lot more to the left to actually rotate versus moving to the right. So this allows me to hide the cursor in the middle and lock it to the center point. Now, if I press escape, I can then view this once again. But that's what I added in. That's what I started off with the rotation of the turret. So let's take a look at that real quick. So I have one in here called turret rotation. So I'm going to edit that graph now. So this is where we last left off in the last live stream. And I'll go into full screen for this. So right at the start of this, I set the cursor set visible to false. So with this unchecked, that means this is false. I no longer can see the cursor, and this right here allows us to set it to the center point of the screen and then lock it there. So cursor, set lock state, locked. We also have none and confined. I believe confined is for a different type of locking. I don't quite remember what it was for. And then none allows us to unlock it. So if I want to pull up a menu, I'd want to set this to true and then set this to none. That way I can start using my cursor again. Okay, now we're going to be modifying this a bit. We're going to include the turret rotation within here, and we're also going to include the shooting mechanic in here as well. The shooting mechanic is going to be a bit more complex, but I think we can get it done within this live stream. Now, before we take a look at the turret rotation, I am going to need a number of different variables, but I first want to discuss how this rotation is going to work. So I'm going to jump out of full screen, and we'll take a quick look at the script we'll be using. So I'm going to be referencing the script that I've already created, and then we're going to convert this within Visual Scripting. Okay, so let me take a look at the script, and it'll pop up over here in the inspector as a preview, but I can see the entire script through there. So I'm calling it turret lag, and I actually have two different scripts for this. I have one for the turret lag itself, and then the tank shooting, but we're going to combine them within Visual Scripting. There's a question. I remember you said you lived in Japan. Are you in Japan right now? No, I am in San Diego, California. I haven't lived in Japan since 2010, so that's when I left. So it's been a while, almost as long as I've been there. So I was only there for a couple years. I don't live there now. I've been in the U.S. ever since. Yeah, so Japan was my last overseas stay, if you will. So I've been living in the U.S. ever since, and I've been living in California for the past 5 years. Okay, so let's continue with this. So first I'm going to replicate this, but let's actually go over what this looks like, and I'll actually go into Visual Studio to make this easier to read. Okay, so with the turret lag, the way this is going to work, and if you've been through the tower defense game, the turrets in that game actually utilize a very similar mechanic to this. So when I move my mouse left and right, I want to rotate an empty game object. So this is an object that we're not actually going to see in game. But we're going to rotate this because this will be our reference point of a rotation that I want to go to. So we're going to rotate this directly with the movement of the mouse. And then we're going to rotate the turret. So we're going to have the turret catch up to the empty game object. Okay, so that's why these are two separate objects. And we are going to be modifying our tank prefab to move the camera to be attached to this empty because I want the camera to rotate independently of the turret itself. So if you've ever played Battlefield 5, they have a very similar mechanic there where if you rotate your camera, when you're in a tank obviously, when you rotate your camera, you can rotate very quickly, but the turret actually takes a while to catch up. So if you fire your turret as it's rotating around, the bullet or the shell is going to come out of the barrel, but not in the direction that you're looking at unless the turret is actually there. So that's why we have two different transforms for that. We have a turret delay, so how quickly will that turret catch up to the turret empty rotation? We have MoveX, Now we're only rotating along the y-axis, so I want to have a singular value for that. I'm going to be using MoveX with the mouse X rotation, and I don't want to rotate along the X or the Z axis, but I just want to use this singular value to rotate the y-axis. And then finally, we have a public float turret rotate speed. So turret rotate speed allows us to determine how quickly I can rotate the camera and the turret empty. So if I move left and right, if I don't have a multiplier, it's going to look very choppy. It's going to be almost instant, but it's going to be very choppy. With the turret rotate speed, I can move it very quickly, very smoothly. I'm using update to call one specific method called rotate turret. Notice that I'm using update and not fixed update because I'm not using a rigid body. I don't need to use fixed update with this. Okay, so this is the meat and potatoes of how this works. I first calculate MoveX. Now in visual scripting, I'm not actually going to be creating this variable. I can just use this value directly down below here. But basically, I'm taking the mouse X, which is the left and right axis value of the mouse movement, and I'm multiplying that by the turret rotate speed. I then take that value and I say I only want to rotate the turret empty along the y-axis. So here we have turret empty.rotate X, Y, and Z. I'm not rotating along the X or the Z axis. I just want to rotate along the y-axis based off the value that we have up here. And then finally, for the turret rotation, this is the physical turret itself. I'm not actually rotating this directly with the mouse. It's based off what the rotation of the turret empty is set to. So we're using quaternion.rotate towards. And this is very similar to something we've done before, but basically this allows us to go between the first rotation, so where the turret is currently at, to the second rotation, which is the turret empty. And then this last value is basically allowing us to determine how quickly it will get to that second rotation. So we're multiplying time.delta time times our turret delay. The higher the value for the turret delay, the quicker it's going to catch up. Okay, so quite a bit to go over there, but we're going to go over this in visual scripting. So I'm going to close this up. And I'll keep this opened up on the side here. So I am going to be using update for this. Now the first thing that I want to do is I want to ensure that I have a turret empty, and we also have a separate variable for the turret itself. Now before we take a look at creating those variables, let's go and set up our prefab to include the turret empty with the camera. Now in the latest versions of Unity, if you have a prefab, it'll show up blue like this. If I try to modify this, it's going to tell me that I can't modify it unless I unpack that prefab or somehow break this prefab. So to unpack this prefab, I'm going to right click on the tank_live, go to unpack prefab, and now I can modify this like any other object. Now the reason why I want to do this is because right now the camera is attached to the turret. So if I were rotating the turret back and forth, it's actually controlling the movement of the main camera. Now that would work fine if the main camera and the turret should be moving at the exact same speed at the same time. But in this case, I want to decouple those and have the turret rotate after I've rotated the camera. So I'm going to take the main camera. I'll drag this out of the turret. Let's go back into our scene real quick. The camera is currently right here. Now, if I rotate the camera left and right, I want to ensure that I have the pivot point for the camera set right here, right where the turret is at. So that's where the turret empty is going to reside. So I want to make sure that the turret empty has the exact same rotation and position as the turret. So I'm going to right click on a turret. I'll create an empty. And I will call this turret empty. Okay, pretty self-explanatory. I'll drag this out. This will be a separate object. And now I'll take the camera and drag that underneath the turret empty. So now if I rotate the turret empty, you can see the camera rotates based off that pivot point. Okay, and once again, we have the z-axis pointing forward, the y-axis pointing upward. Okay, so let's see. I think I'll update this prefab later on once I'm done with all this stuff. For now, I'll leave it as is. But we need to create a variable for the turret empty and also one for the turret. So we have a growing list of variables over here. So I have the turret delay already in here that was created in the last stream, but I need to include a transform for the turret empty and the turret transform. Okay, so the turret empty is going to be a transform. I also need one for the turret. That'll also be a type of transform. Okay, and let's see. I'm just going to go and drag these in for now. I will use those in a moment. I'm also going to be using the turret delay. And then I believe I have another variable that I created in the last stream. It is a private variable, which is known as a graph variable. So if I jump into full screen, we can create a graph variable which is specific to this graph, meaning I can't access it from another graph. So it's kind of like a private variable. But for this, let me jump out of full screen again, and I'll take a look at my turret lag. So I have the variables for the turret empty and the turret. We have the turret delay, which was already created. I need to create a float for the move X. Actually, we're not going to use a move X float. We can just use that directly down below. But I will need one for the turret rotate speed, which is a public one here. Let's see. I'm going to get a graph variable. I'll just hard code this basically, and I'll set it to a value of 3. I don't need to modify that really in game, so I'm going to leave that as a graph variable. So with the graph variable, I need the turret rotate speed. And I need to get this value. Okay. So in update, I'm going to be updating the move X. To update that, let's go and move some of these around a bit. I need to get the mouse X input axis. So I'm going to add in a unit here. It's input axis. So input get axis. Connect this up to update. I need to provide the axis name, which is mouse X as such. So mouse X with a space in between capital M, capital X. And let me go ahead and move this over here so we have a bit more room. Okay, so I need to get this input axis. I don't like hard coding things unless I know I'm not going to be modifying them later on. But in this case, I know that I've never changed that value, so I'm just going to hard code it. Okay, so I need to get the turret rotate speed, and I need to multiply this by the mouse X. So I'm going to add in a multiply node. Okay, and that's going to be the value that we're using for the y-axis down below. So here I'm multiplying the axis by the turret rotate speed. Now here I actually assigned that to a value called, or a variable called move X. In this case, I can actually use this directly without creating a variable for that. So this just saves me a little bit of time. And with this, I need to use a rotate node or a rotate unit. So I'm looking for transform rotate. And I'm looking for the one that has the X, Y, and Z axis available to me. So this value here is only going to be applied to the Y axis. The X and the Z are going to be left at 0. And I'm not rotating self. This is going to be applied directly to the tank. So I need to specify what I need to rotate. This is going to be rotating the turret empty. So I'll plug that in where it says self. And I'll plug this across here. And let me go ahead and move these down a bit. I'm getting a little crowded up there. Okay, let's see. Let's go and move these down a bit. So now I've calculated this down here. I've rotated, I provided the value to rotate the turret empty, but now I need to set the rotation for the turret empty. Make sure I'm connecting everything correctly. So we have turret empty, multiply that. Okay, that's set up. So we covered that line. Next, we need to actually rotate the turret itself. And I have that right here. So I need to use a transform rotation. I want to set the rotation. Now in programming, as you can see here, we set turret.rotation equals this, but with visual scripting, it's kind of reversed. So this goes at the end. I need to calculate this quaternion.rotate towards. So I'll do that first, and then the output of that is going to be connected to this. So I think I can pull it up by just saying rotate towards, and I'm looking for the one that says quaternion. Now with the quaternion here, with this node, let's go and connect this up here. I need to provide a rotation that we're coming from, and then a rotation I'm coming to. And then finally, this last one is going to be our speed. So how quickly we rotate to that new location, or to that new rotation, I should say. So I'm going to calculate the max degrees to delta down here first. We're going to multiply the time delta time by the turret delay. So I'll add in a unit for the time delta, and I want to get the time delta time. We'll multiply these. And we'll add this down here. Now again, the higher the value for the turret delay, the quicker it's going to rotate to the second rotation here. Now the first rotation is going to be where we're at right now. So I want to get the current rotation of the turret. So I'm going to add units, get rotation, and I'm looking for transform get rotation. And more specifically, I'm getting the rotation from this turret. And I'll plug that in for the from. Now the 2 is going to be the rotation of the turret empty. So similar to what I did here, let's give ourselves a bit of room here. I'm going to duplicate these two. Plug this in here. Instead of actually moving this down here, I can just swap this out with the, was it turret empty? So I'm getting the turret empty rotation, and I'm using that as the 2 rotation. After that, I can then plug these in straight across. And again, once again, I need to provide the object that I'm actually rotating, which is the turret. So I'm going to duplicate this and use that instead of self. Okay, so once again, let's go through this very quickly. We're going to update this. So whenever I move my mouse left or right, that is mouse X, I multiply that by the turret rotate speed. That will then allow me to actually rotate the turret empty along the Y axis. I'm not rotating along the X or the Z axis. Let me see a logical way to go through this. So I then use that value. After that, I set rotate towards. So this allows me to rotate the turret itself, the physical turret, based off the rotation of the turret empty. So I take the rotation that we're currently at with the turret, then I say I want to move to this new location based off this speed. So we're using time.delta time times our turret delay to determine how quickly I will rotate to those new rotations. And then finally, this just calculates the value. Once again, like we did here, I then need to apply that rotation to the turret. So I'm going to create a group for this. Okay, I'm going to call it turret lag. And before we take a look at the shooting with the barrel moving in and out, I want to make sure that this works as intended. So let's go back into our scene. Let me make sure I quickly save this just in case it crashes. Okay, so we have the turret empty assigned. We also have the turret transform assigned. And I believe we have everything assigned for the graph variable. So we have the turret rotate set to 3. And the turret delay right now is at 1. You'll see it move very, very slowly. But we'll test this out. Let me drag my scene window down and the game window down because we can't actually see the barrel. Or we can't, it's very hard to see from this angle, so I'm going to have a different angle here. And we'll click play. We can also see it moving over here in the graph. Okay, so there we go. It's moving very, very slowly. I can move my camera very quickly. So if I see someone trying to sneak up on my tank, I can look behind me. And you can see that if I pass basically the center point of that turret, it actually rotates in the opposite direction. Now, that's not very realistic, but if I was actually playing this in game, I would want to have that set up, because if I go all the way around, I don't want the turret to go all the way around and potentially lose my tank because it's taking too long to snap around. So we know this works. Let's just increase the speed of the delay. And I think I could do this live. Let's see. So right now the turret delay is set to 1. Let's bump this up to 25. Okay, so when I bump it up to 25, it's much, much quicker. Okay, and it doesn't overshoot with rotate towards, which is great. It's not going to go past the point where I want it to go. It just stops right there. Let me switch this back over here. Now I do want to move my camera because it's basically right up behind the tank. I want to be able to actually see in front of the tank. So if there is something in front of me, I want to be able to shoot it, but I need to be able to see what's there. So I'm just going to move the camera up. I'll leave it as a child of the turret empty. Just move it up. And let me do this with the game view on the side here. So I'll move this up like this. Maybe even rotate it down a bit along the x-axis. And if I have time at the end of the stream, I'll add in a crosshair in the middle. That'll act as our reference point of where the camera is actually at. So there's a question, what happens when you rotate the tank? I'm not really sure what you're asking. I'll go ahead and play it and I'll show you. So if I rotate the tank, these two pieces are actually independent of each other. And hold on, I don't think I actually saved the turret delay value. Bump that back up to 25. That didn't save because I was modifying it in play mode. But let's play it again. So the turret itself is controlled independently of the actual tank. So I can move and rotate, and I can also look in another direction. And you can see how that works. I'm not sure if there's another question on that. Well, basically I want to have these independent of each other like a real tank. So if I'm trying to evade another tank that's trying to shoot me, I can still move in this direction and shoot in that direction. I hope that answers your question, Towels. Okay. All right, so we have the turret lag in place. Now let's take a look at the movement of the barrel. So every time I fire, I want to instantiate a projectile. So this projectile is going to come out of the barrel, and it's going to be a physical projectile, so it's going to be flying through the air. And then when it hits something, it'll explode or whatever we want to do. Now, along with that, a nice little feature is to have the barrel move in and out. It just adds a nice visual detail to the tank. Now, we may or may not be able to see this from this view, but if we are playing this in a multiplayer game or something of that sort, we can see that. So I want to be able to control this through script. This is going to be a little bit more complex, but it is going to be a nice visual feature for this tank. I'm going to include this in the same graph up here. So before we take a look at adding it in the graph, let's take a quick look at the script. I'm not going to go through every single thing in the script. I'm just going to kind of briefly overview it because it is a long script. Okay, so, nope, not you. So within this script, we have a number of different things in here. I'm not going to include everything from this script. We have stuff like the barrel itself, the transform of the barrel. This is the object I actually want to move. We have the recoil speed, so how fast does it move back, and the recoil amount. Now, I only want to move the barrel along the z-axis. This is a local axis to the barrel. So I'm going to be moving this back and then returning back to the original position after we're done with the recoil of the barrel. So we need to have a barrel recoil amount to be able to fine tune how far back we want to move. Some of the stuff we're not going to include, like the audio clip, I'll probably not include that in this live stream. I did experiment with particle systems with this, again, for another live stream. And then we also have the shell origin. That is something we'll need. This is where when we'll start shooting out a projectile. I need a origin point of where that shell is going to be created and then shot out from. Again, tank shell, that's the physical projectile. And then we have the shell force. So basically all of this is not going to be included right now quite yet. We'll take a look at that later on. All I'm really concerned with is having this barrel move in and out. So let's jump down to that section of the script. So in the start method, I want to make sure that I get the original position of the barrel where we start off at. So I'm storing that within a vector3 called original position. I then also have one called barrel recoil position. This is how far back we're moving, but because I'm only moving along one axis, I want to get the original position.x, so the x-axis and the y-axis are going to be unchanged. The z-axis is the only thing we're modifying. So I'm taking the original position of the z-axis and I'm subtracting whatever we have set up for the barrel recoil amount. So in this case, it'll probably be something small like 0.25. So we're going to move 0.25 in the negative direction, so we're going to subtract that from the original position z. Hello, Miranda. And this allows us to actually move it back. Now, when we come back to the original position of the barrel, we're going to use the original position vector3 up here. Okay? So I'll take a quick look at what we'll create for the shooting mechanic. So with the shooting mechanic, we're first going to look at detecting whether or not we're pressing fire 1, which is left click on our mouse. When I do that, I'm then going to start a sequence, a couple of sequences to move the barrel back and forward. So these are done through coroutines. And what I'm doing here is I'm checking to see if our current speed, which will start off at 0, is less than the barrel recoil speed. So current speed is going to start off at 0. The recoil speed will be set quite low to say 0.5 seconds. So if that is true, I then want to increment our current speed by time delta time. So this will increment slightly to 0.1, 0.2, 0.3, so on and so forth. So every time I go through this, it'll increment just a little bit. We're going to go through visual scripting, Miranda. I'm just going over kind of a preview of what is involved with this mechanic. We have the local position of the barrel. Notice that I'm using local position. I'm not using the world position because if I rotate the turret, the local position of that barrel is going to change in relation to the global position. So with this, we're going to use vector3 lerp. And this is very similar to what we did with the rotating of the turret. I'm taking the original position. This is where we're starting off. I'm moving to this position. And then this last value here is not actually a time value. This is a value between 0 and 1. So if we're at a value of 0 here, we're going to be at this position. If this is a value of 0.5, we're going to be at this position. Or not this position, but somewhere in between these two positions. If this is a value of, let's say this is current speed of 4, and this is also 4, that's going to be a value of 1. So if this value is 1, I'm now at this second position. So we're incrementing current speed little by little, getting closer and closer to matching a value of 1. And then we wait a single frame. So we're going to continue going through this while loop over and over as long as this condition is true. So that's slowly moving the barrel back. And then when we're done with this, I reset the current speed, and then I start the process of returning the barrel back to where it was. It does the exact same thing, except now we're coming from a new position, which is the recoil position, all the way retracted back, and then we're moving back to the original position. Everything else is exactly the same. So we're going to be going over creating these two things here, and also triggering those sequences with the input of the Fire 1 button. So we're going to be adding all the other stuff later on, but for now, that's what I want to focus on. And I know that's a lot of code to throw at you guys. I'm not expecting you to understand any of that code. I just want to kind of give you an idea of how this is going to work before we dive into the visual scripting. Okay, so let me go and move these again. So for this, I'm going to be using a input event. So whenever I press the left click button on my mouse, I then want to start an event. I want to trigger an event. This event will then start the sequence of moving the barrel back. So I'm going to be using an on input. So I'm looking for an on input. So on mouse input, this is an event. And if we take a look here, it says button left. So this is the left click on our mouse. The action will be pressing down. We can also say hold up or hold or press up. Now hold is if I'm holding it down, and then up is when I release it after being held down. In my case, whenever I fire out a projectile, I'm just looking for a single press of left click on my mouse. Now, whenever that happens, I then want to trigger an event. I'm not going to be going through the entire sequence here. Instead, I'll have the entire sequence down below. But first, I need to trigger an event to start that process. So I'm going to create a new unit. This will be called trigger event and trigger custom event. Okay, I haven't created this event quite yet. We'll create that down below. But this is going to be our trigger zone. So whenever I click on left click, we're then going to trigger that event, which will be declared down below. I agree, Jake. So going back and forth between C# scripting and the visual scripting helps to really kind of reinforce how this works. So if you get lost on a C# scripting side, you're going to get reinforced with that in the visual scripting side. So it just kind of helps with either one. You know, I'm more partial to the written code versus the visual scripting, but everyone learns differently. So you get to see both sides of the coin, so to speak. Thank you, Miranda. So we're going to connect these up. So whenever I press left click, I then want to trigger an event called recoil back. Okay, so that is the name. Down below, we have this set to self. This basically says, hey, where's this event going to be created? This is going to be created within this graph, so I can leave this as self. Okay, and that's really all we're doing here. So this is just checking to see if we're pressing a button. If so, I want to trigger this event. So I'll create a group for this, and I'll just call this fire. We're going to be adding stuff to this later on because we don't have anything preventing us from clicking that button multiple times. But this is where we're going to add in a fire rate later on. For now, I just want to go over the barrel moving in and out. Okay, so for the event, we're going to be calling it recoil back. I need to create an event down below here. So let's add a unit, custom event. So take a look at the differences here. Here I trigger an event. Here I create the event. Again, this is based off self. The name of this event is going to be recoil back. It has to be spelled exactly the same. It is case sensitive. Okay, so what do I want to do with the recoil back? Whenever this event gets called, I then want to start the process of moving back for the barrel, and then we're going to have another similar sequence later on for moving it back forward. So the first thing I want to do is use a while loop. So let's add a unit, while. I'll connect this up here. And with a while loop, if I go through here again, right here, we need a condition. So the condition right here, this little pink dot, that is our condition. That has to be either true or false. If it's true, we can then use the body. If it's false, we can then use the exit up here. So what is the condition for this? I want to check to see if the current speed is less than the barrel recoil speed. Now, I don't believe we have either of these variables in quite yet, so I'm going to create those as graph variables. So I need to jump into full screen for that. Okay, so a graph variable, current speed, this will be a float, and I'll set that to a value of 0. We're going to be modifying this through the graph itself, so I'm not assigning a value to this. Down below that, we have barrel recoil speed, so it's quite a mouthful. So this is also a float, and this is how quickly we recoil back with the barrel. So I'm going to set this quite low to 0.25 for now. So 0.25 seconds for it to go all the way back. Okay, so I'm going to drag in the current speed and the recoil speed. And within the script, I was checking to see if this value is less than the barrel recoil speed. So this will be starting off at 0. This will be starting off at 0.25. So this will be true with the while loop. So let's add in a less. So with the less unit, I check to see if this is less than this value here. I then connect this up to the while loop. So if this is less than that, this will then be true. Then we can start going through the body. Now the first thing that I want to do within the body is I want to increment the current speed by the time delta time. So every time we go through the while loop, we're automatically incrementing this value just a little bit every single time we go through the loop. So I'm going to get this variable because I need to add it to our time delta time. So I need an add unit. I also need a time delta time unit. So time get delta time. Plug these in here and here. And then I need to set current speed. So I get it. Now I need to set the new value based off what we added here. So to set a value, I'll just do it over here. I'm going to add a unit. I'll say set current speed. Okay, and I'll connect this right here where it says body. So now it's going to update this, and I'll connect this right here, and there we go. So now every time we go through this while loop, it's incrementing current speed by just a little amount. Now we're going to need quite a bit of space here because now we're going to be actually moving an object. We're going to be using vector3 lerp. We're going to be doing a number of different things along with this. So I'm going to add in a few nodes and we'll connect them up in a moment. So I know I need a vector3 lerp. So vector3 lerp. And we can connect this up straight here. So with a vector3 lerp, we need two vector3. So these are the positions. We have a starting position and we need a secondary position. Now, one thing we forgot to do up here, and I'll do that in a moment, but the starting position is going to be called original position. This would be a vector3. So this is where we start off with the barrel in its original state. The second position here is one that we need to calculate based off that original position, and we're going to add that with the barrel recoil amount. So we're going to come back to this in a moment. We need to create those variables first. So right now I have my tank selected, so I can switch back to object mode and add an object variable. I can then modify this through the inspector. But because I am going to be assigning a few things to this, let's see, yeah, let's get out of full screen mode because I do need to assign the barrel. So I'll add them over here. It's the same process. So I need to add in the barrel, which is a transform. And I'll add that in now. And let me just take a quick look at the script, make sure I don't have any other public variables I need to add in. So the recoil speed, yeah, I'll make that public. I think I already have that in there. I do not. Okay, let's add that in. So the barrel recoil speed, I think I made that a private variable. Maybe jump in real quick. Yeah, I did. Okay, that's fine. So I can delete it from here. Let's see. Recoil speed, recoil amounts. Do I have that in here as well? No, I don't. I'll make that a object variable just because I want to be able to modify that through the inspector. So that'll be the barrel recoil amount. And that will be a vector3. And I'm going to be modifying that through the graph here. And I think we have enough for now. So I'm going to say in full screen here, I need to add in a couple of vector3s. These are going to be graph variables, the original position and the recoil position. So I'm going to add in a original position. This will be a vector3. Okay, I'm going to be modifying this through the graph. We also need one for the barrel recoil position. This will also be a vector3. So I'm going to be using the barrel recoil position along with the recoil amount. And I'm going to do that in start because right when we start our game, I want to get these different values. I want to assign them and have everything ready to go so that when I do fire, I can then use them down below. So I'm going to do this in start. I do have a start node right here, but I want to keep this separate. So I'm going to create a whole new group for this altogether. So I need another start unit. I'll duplicate this one. So right when I start, I want to get the local position of the barrel. So let's drag the barrel. I want to get the local position of this. If I forget to add in the local position instead just get the position, that'll be a world position. And when I fire, you'll see the barrel returns and then it floats up into the air because it's based off the world position. So local position ensures that it stays with the tank whenever we fire. Okay, so I'm going to get local position. and I'm getting that from the barrel. And then I want to set that value with the, where's it at? Original position. Oh, I need to set the original position. So I'll connect this up here in start. Now, whatever we have for the barrel position, that'll be our new original position. So I'll connect this up here. And then from here, I then want to also calculate the barrel recoil position. So I want to set this. Again, hold on Alt, left click and drag this in. Or also, if I'm using this, I can right click in here, add unit, set barrel recoil position, and all that kind of stuff. Okay, now with the barrel recoil position, and I'm jumping back and forth a lot here, so I apologize. But with the barrel recoil position, I only want to modify one axis. So to take a look at what axis we'll be using, I'll jump out of full screen again, jump back into our scene, and we'll take a look at the barrel. Let me just take a quick look at chat. Okay, so with the axis here, the blue arrow is the z-axis. So when I fire, I want this to move in and then move back out. So the starting point is where the barrel is currently at. I'm then going to subtract whatever we have for the barrel recoil amount by what we have at the starting point of the z-axis for that barrel. So let's say I subtract it minus, if I type in -5 or minus 0.5, that's how far it's going to move whenever I subtract 0.5. Now, obviously, that's way too much. So if I subtract negative 0.25, that's about as far back as I want to go. So 0.25 will be a good value for moving back. And then when we return, we're just going to go back to our original position. That's why we're storing that value for the original position. Okay, jump back into our flow graph. So I only want to modify the z-axis value. So I need to get the y-axis and the x-axis from the original position and use that in conjunction with the recoil position. So we need to create a whole new vector 3, and then whenever we combine all that kind of stuff that we need, we then assign that value to this guy. So I need to create a vector 3. And I want the one that has the x, y, and z exposed. And actually, I don't need to get this variable. I need to set it. So I'll delete that for now. But what I need here is I want to get the y and the x axis from this. So I need to use a couple more units. I want to get x. So I want to get the x axis from this. So I'm looking for vector 3 get x. This will allow me to get just the x axis from the original position. I'll pass that along to this create vector 3. I need to do the same thing for the y-axis. So get y. And then for the z-axis, we're still going to use a get z, but now we're going to be adding to it. So I'm going to create another unit once again, get z. Okay, and I'll give myself a bit more room here. We're getting a little crowded here, but I want to add what we have for the current value of the z-axis plus the recoil amount. I'm going to jump back into full screen now. So we have the object, the barrel recoil amount, and actually this should be a float because we don't need the x, y, and z. This will be a value of 0.25. So we've already calculated that. We know how far back we need to move along the z-axis. I'm going to add that to the z-axis of the original position, then pass that along to the create vector 3. Let me go ahead and I'll move this up a bit so these guys aren't crowded down below. Okay, so I'm going to add these two values. Actually, not add, we're going to subtract. If we add them, it's going to move forward. So I want to subtract the z-axis value minus the recoil amount. So we're going to subtract 0.25, and then we're going to pass that along for the z-axis over here. And let's see, connect this cross over here. Okay, so we created a vector 3. Now I need to set the value that what we have here to the Where is it at? The graph here, the barrel recoil position. Hold on Alt, left click, and drag this in. Connect this up here, and then pass this along here. Okay, so we have the original position, and now we also have the recoil position. So create a new group for this. And I will call this barrel, barrel recoil setup. Yeah, I'm trying to keep these nice and organized. I'm trying to organize them in a way that these would be like individual methods. So each little block here represents some sort of mechanic or some sort of action that happens in game. Okay, so now we can jump down here for the actual movement of the turret. So for the Vector 3 lerp, again, we have the starting point, the ending point, and then the value between those two to determine which point we're going to be at. So the starting point is going to be the original position. So I want to get the original position. I'll plug that in for A. And then I want to get, I'll duplicate this, and I want to get the second one, which is the recoil position. That'll be B. Now T is going to be based off the current speed divided by the barrel recoil speed. So I'll duplicate these two. And I want to divide these two, and then the output of that is going to be what we have for T. Okay, once again, we're just calculating values. Now we need to actually physically move the object. So the object I want to move is the barrel. So let's go back to our object variables here. I'll drag the, let's see, I want to set the barrel position. So let's add that in first. Set position. So transform set position. And then I want to specify that I want to move the barrel. Okay, so connect this up to where it says self. Connect this up right here. So this is the position I want to move to. And then we'll connect this up here as well so it updates every single time we go through the loop. Now, after I set the position, because we are replicating a coroutine, I want to wait a single frame. If I leave this as is, it's all going to happen super quick. It's going to look like it didn't do anything at all. So we need to wait just a single frame at the very end before we continue to go through the entire loop again. So right after the set position, I need to use a wait for end of frame. Okay, and I'll move this down just a bit. Now this works fine. When I press the left click on my mouse, we're then going to trigger this event, which will go through this entire process. Now when we move all the way back, we need to be able to actually do something else. So for now, what I'm going to do is I'm going to create a group. We'll test this out, and then we'll test out how we can use the exit portion of the while loop. So this will be the recoil back. Jump out of full screen. Once again, I'll move my game window down. And I'll move my scene window over here. Let's actually move the game window up here. Trying to get everything in view here. And let's make sure that we did assign the barrel and all that kind of stuff in here. Okay, good. Okay, so we did have an issue here. If I take a look at this, this is what I was talking about before. If I use the global position, so the barrel's right here. When I fired back, it moved to this weird location, and it's basing it off the global coordinates. And I'm pretty sure I know why. So there are a few issues we're going to fix right now. Jump back into full screen. Now the reason why it moved like that is because I'm using set position. I need to set the local position of the barrel. So I'll add that in now. Set local position. Plug this in here. Let me go and delete this one for now. Now the other thing right here, I'm not really entirely sure why this turned red, but I believe it's because I'm trying to use a coroutine down below here, and I have not set this up as a coroutine. Anytime I use any of these weight units, I need to specify that this is going to be used as a coroutine, and that needs to be set up with the event. So on the event itself, we have the option to enable coroutine. So if I check that on, we get this little symbol here letting us know that this can be used as a coroutine. And you can see down below here, the error does say, hey, we can't use wait for end of frame with this because it's not set up as a coroutine. Okay, so now I can try this once again. And this is why it's important to test things out before you go too deep with these mechanics. And I'm a little bit too far from the tank. There we go. Okay, so right now it's fully retracted. I'll play that again for you guys. Let me deselect that tank. Okay, so that's where the barrel is currently at. When I press left click, it moves back, it retracts back into the tank. Now, I need to do the reverse to go back forward. So we've done basically all the hard work now. All we're doing now is going to duplicate what we have for the recoil back. We're going to reverse a few things, and then we can return back to the forward state. So again, I'll jump back into full screen. I'll duplicate all this. And before we take a look at the duplicate, there is one other thing we need to modify within the recoil back. Because I want this to actually feed into the second portion here, when I exit out of the while loop, that's when I can then call a trigger, a custom event trigger, and then the event will be called down below here, and then start the process down below here. But I also want to be able to use the current speed once again down below here. Right now, we've incremented the current speed all the way up to the value of the barrel recoil speed. So if I don't modify this once again after I leave this section, that current speed is going to be equal to 0.5. And then when we get down here, it's going to say, hey, we're at the exact same speed, just automatically jump forward back. And we don't want that. We want to have the same forward and backward motion. So right when we end this while loop, when we exit, I want to reset the current speed back to 0. And then I want to trigger an event, which we'll be using down below here. So let's reset the current speed first. So I need to set the current speed. And let me go ahead and move some of these down a bit and over. Let me expand this out because I am going to add in one more node above that. Okay, so I'm going to set the current speed. I'll connect this up to the exit portion of the while loop. I'll then take the output of this right here. This will allow us to actually provide the value that we want to use with the current speed. So if I drag this out, it will automatically select float literal at the very top. That's the value that I want to use. And we're going to leave it at 0. So I'm resetting the value of current speed back to 0. And then after that, just like we did up here, I want to trigger a custom event. So I'm going to duplicate this one up here. I'll connect this right here. Once again, we're basing this off self, but the event name is going to be different. So I'm going to be calling this barrel return. Okay, once again, this is case sensitive, so we need to make sure that we do type it out exactly the same way down below. We have almost the exact same setup as before. Let's rename this now to barrel return. And now whenever we exit this while loop, we're automatically going to start this one down here. Now this is exactly the same as up above with a different custom event. So I need to modify a few things here. I don't need to go from the original position back to the recoil position. I need to invert those or reverse those because now we're at this position and I want to move back to the original position. So all I can do here is swap these out. So I'll right click on these to disconnect them. First, we're starting off with the recoil position. That'll be A. Then we're going down to the original position. That'll be B. Everything else is exactly the same. Now, once again, just like we did up here, I want to reset the current speed back to 0 because when I return that barrel back forward, I want to ensure that the current speed is back to 0. Otherwise, we're going to have that same issue once again when we enter the recoil back section. So I'm going to duplicate both of these. And after we're done with this section, I'm not going to be triggering any kind of event. We only go into the recoil back if I press left click. The recoil, the barrel returning forward is automatically going to happen after this finishes. So I'll move these down a bit. And this will be the barrel return. Okay, let's give this a quick test again. Looks like it was firing multiple times. I'm not sure why. Let me disconnect this one real quick, make sure it's working. So it looks like it's recoiled back, that's set up properly. The only thing that was changed up here was the current speed. That's based off exits. Not sure why it's pumping like that. Okay, that's set up properly. That's set up as a coroutine, that's fine. These are swapped. Visual position, recoil position. Okay. Let's take a quick look at a completed version of this because I did this before. Because this looks completely identical. So I'm going to swap out a I created these earlier. I've never had it pump like that before. I'm not entirely sure why it's doing it now. Because it looks like it's going through multiple times. Every time I press the button, it looks like it's calling it multiple times. Let me actually decrease the speed of the recoil amount. I'll set this up kind of high, or not the recoil amount, but the speed, the barrel recoil speed. We'll bump this up to about 5 seconds, and then we'll test it from there. Okay, that seems to be working fine. Technical position, all that set up. The worst part about this is that there's so many nodes in here that there's probably something small. Recoil speed. Because it only happens when you reset the current speed. Okay, if I can't figure it out, I'm just going to swap out the one that I have right now that I created because it looks identical. So I'm just going to swap out the one that I have that I know works. So I called it turret lag. And then I need to go in here. This is based off a graph variable. We'll probably get a few errors because I did use different types of variables for the other one. Okay, so there's one. Okay. In our play mode, we'll switch these out. So this is a graph variable. Recall position, current speed. not add that variable in here? I'm gonna add it in now. Barrel recoil speed. 0.25. Of course. Okay, so this is a graph variable as well. Of course. All right. So I don't know what's going on right now. Let me take a quick look at the script and then we'll see what went wrong here. Okay, so in a script, we're adding current speed plus time.delta time. And I guess while we're at it, I'll just swap out the turret lag for the turret rotate. Okay, so when I press fire 1, which is left click, we're going to be calling recoil back, which is down here. That is a coroutine. We're going to start the while loop. So current speed is going to be less than the barrel recoil speed. So this will be 0, this will be 0.25, that'll be true. We're then going to increment current speed by time delta time in the body. That's what we're doing here. So current speed plus time.delta time. We set that variable here. And then I get the variable for the current speed divided by the barrel recoil speed, and that is the same one as over there. We divide those, that'll be a value for t. We use the original position, that's the starting point. We're moving to the recoil position, that is the second point. Then I set the local position of the barrel based off the vector3 lerp. Then we wait a single frame, and then we repeat the process until we go into exit, in which case we reset the current speed to 0, and then we trigger barrel return. Okay, barrel return is down here. Okay, well, you know what? I'm just going to go back into another scene, which I've already partially completed. Awesome. So Unity just froze or crashed or something. Okay, Unity just completely froze for me. Let's reopen Unity, yay! That's the first time that Unity has ever crashed for me in a stream. Thankfully, I didn't lose any of the stuff that I was working on. Now it's working. Okay, so I'm just going to continue with this. I'm not sure why it wasn't working for the other one, but I'm going to continue with this one. It has everything that we need. So you can see here, if I left click, it'll just recoil back. It's a little bit slow. We can increase the speed so it moves back faster. And it moves back to where it was before. And you can see over here, if I zoom in a bit here, whenever I shoot, it goes through this top section. And then whenever I finish that top section, we then go to the barrel return at the same speed at which we move back. So let's take a look at how we can also implement the firing of the projectile along with this. Now I think what I'll do is for the projectile, I'll base it off this fire group here. So whenever I left click, I then want to fire out a projectile, and then I want to trigger this event. So I'm going to move some of these down a bit. And it looks like my lighting is trying to bake right now. Hopefully it doesn't cause any issues, because I did have to reopen Unity. It is rebaking out my lighting. And I'll set this quite low. Let's go down to 1, 32. Okay, so whenever I left click, I want to be able to determine how long we can take between shots. So I don't want to be able to keep clicking over and over again and keep shooting out multiple projectiles within, half a second of each other. I want to be able to have some sort of timing in between these. So I'm going to have a fire rate value, and I also want to be able to actually shoot out a projectile every single time I press left click. So I'm going to expand out this group. And I'm just going to try to match it up with the rest of the groups here. Now what we'll need for this is we'll need two float values. One is going to be the fire rate. So this is something that we dictate ourselves. So I'm going to set it for, say, 1 second. So every 1 second, then I can fire out a projectile. This will also determine whether or not I can actually go through the process of moving the barrel in and out every single time I left click. If I press left click in between that fire rate, it's going to completely ignore it. So I'm going to move this out. I'll disconnect this for now. And in the flow machine, or the variables group here, I'm going to add in a variable for the fire rate. And then for the other variables, I'll make those graph variables. So for the variable, for the fire rate, we'll call it fire rate. This will be a float. And I'll set this to a value of 1. So that's 1 second between each time I can fire. Okay, I'm going to be using this in conjunction with another float. This will be called next fire, and we'll be calculating that in the background, so to speak. So I'm not going to be doing that over here. I'll just make that a graph variable. So I'll start off with that first. And let me pull up the script real quick so I can kind of go back and forth between this. So in the tank shoot, we have the mouse input. So I'm looking right here where it says turret recoil. I'm looking for an input of fire 1. Whenever I press that, I can then do something with that. But I'm also checking to see, so we have input get button down, fire 1, and if time.time is greater than next fire. Time.time is the amount of time that has elapsed in game. Now, if that is greater than next fire, if my next fire is, say, calculated down below here with a fire rate of 1 second, that means every 1 second that passes in game, I can then fire. So let's say 0.25 seconds have passed in game since the last time I fired. It's not going to do anything in here. It's going to detect that I am pressing fire 1, but I also need to ensure that the time.time is also greater than next fire. So we'll add that in here. I'll calculate that first. So I need a next fire variable. I'll make that a graph variable. That'll be a float. So I'll jump into full screen. Next fire. This will be a float. And I'm not going to add anything in here yet. That's something we'll calculate in here. So I want to get next fire, and I also need to set next fire. So I'll drag it in here to get it. Hold on, Alt, drag it in to set it. So if I press left click, and I'll say and, so and allows us to check to see whether or not two things are true. So if I did press mouse 1, and in this case, I can't actually use it this way. Let's see. Yeah, so I'm going to have to get rid of this mouse input, but I can replace it with something else. So I'm going to be looking for input, get button down. And the button I'm looking for is fire 1. And with this, I will need to use update. So let's add that in now. So if I press fire 1, this will then be true. I'm going to connect that up to the AND node. And then I also want to check to see if time.time is greater than next fire. So I'm going to add in a unit for time. So I want to get time. Now, if this is greater than this, that will then be true. And let's see. I don't know if I need to connect these up. Yeah, let's go and connect those up. So I'll move this down here and over here. And it's going to be a bit of a spaghetti, but I want to make sure I update that. Okay, so if these two things are true, if I'm pressing fire 1, which is left click, and this is also true if time.time is greater than the next fire, I then want to calculate the next fire. So next fire is going to be whatever we have for the time in game plus our fire rate. So, I want to get the variable. That's why it's showing up orange. Let me reverse these and to get this variable. There we go. Now I don't need to have that spaghetti code there. It's getting a little late in the day and it's hot and I'm making little mistakes. Okay, so if these two things are true, I then want to calculate next fire based off the time in game. So I'm going to duplicate this once again, plus the fire rate. So for the fire rate, let's jump back into the object mode here. I'll drag the fire rate. Come on. So I'm going to add these two together. And then I'm going to set the value of this to whatever we have for next fire. Now with this, I need to use a branch. That way we can continue the rest of this. So if this is true, I'll connect this up here. Then I can then calculate next fire. If it's false, I'm not going to do anything at all. Okay, so quite a bit in here just for calculating timing. Then after that, going back into our script, so I'm calculating the next fire, which is right here. It's time.time plus our fire rate. I then want to start the coroutine for the recoil back, which is this guy down here. And then after that, I then want to shoot out a projectile. So let's just connect this up here. And then for the shooting of the projectile, I think I'll create that as a separate group and then have back-to-back events that are going to be triggered. So I'm going to duplicate this. And this would be the shoot projectile. Again, this is based off self. Okay, so I'll put the group over here. This would be for the shooting of the projectile. So now we're done with the fire rate. If the fire rate is set to 1 second and next fire is at 0.25, or whenever we try to fire again, we're at 0.25, it's not going to allow us to fire unless the time in game has surpassed what the fire rate is currently set to. Okay, so right next to this group for the fire, that's where I'm going to have the shoot projectile. So for the shooting of the projectile, let's scroll down a bit. Oh, it's actually up here. So for the shooting of the projectile, we need a rigid body. We're going to be applying a force to a rigid body that will allow it to actually fly forward. Now I need a variable for the origin point of where I want that object created, and then we can apply a force to it. So let's go back to the tank. I'm going to add in a variable for the origin point. This will be an empty game object directly in front of the barrel. So this would be, let's call it projectile origin. And this would be a transform. And I'll jump back into the scene view here. So the projectile is actually going to be created directly in front of the barrel. And it's going to happen so quick that we don't even see it actually being created right here. It's just going to look like it's flying out of the barrel. But this is going to be the origin point of where we want to create this object, in this case the projectile. So going back into the tank, I may or may not need to actually unpack this prefab, we'll see. But I'm going to go down into the turret and then the barrel. I'm going to right click on the barrel, add a empty by create empty. Okay, there it is. And I'll call this projectile origin. Okay, so now I want this to fly out along the z-axis, the local z-axis of the barrel. Go back to the tank. Let's assign that, and this went back to null. Let's set this back up to transform. I also need a reference to the projectile. Now, the projectile is going to come from the project. I have created a projectile already. So if I go into my prefabs, go to the tank shell, this is what it looks like. Very simple projectile. And if I open this prefab, it has a capsule collider, which allows us to detect collisions. And it also has a rigid body, which gives it mass and gravity, but also allows us to apply forces to it. Now we're using this from the project because I want to create a template of this. This is our template for what we want to create in game. If this actually resides in the game and we try to create that object, once that object gets destroyed in game, I no longer have that reference to actually recreate that object over and over again. So coming from the project, we're providing a template for how to create that object in game. And since I don't destroy anything in the project, I always have that reference available to me. Okay, so let's go back into our variables. Let's add in one more for the rigid body. This would be the tank shell. Drag the tank shell in there. And then we need one more variable for now, which is going to be the force that we apply to the tank shell. So I'll say shell force. This will be a float. And I'll give it a value of 30 for now. We can increase this later on if we want to. But let's drag in the tank shell, projectile origin, and the shell force. Okay, so we about have half an hour or so left. This is probably all going to be covering for the rest of the stream, just covering shooting out of the projectile with the barrel. So let's go over creating the custom event for the shoot projectile first. So I need to create a custom event called shoot projectile. And this will not be a coroutine. All we're doing here is we're going to instantiate a projectile. So I need to create a node in here for instantiating a projectile. I'm going to say instantiate. And I'm looking for the game object instantiate with the original, position, rotation, and then, yeah, just this one right here. So whenever this event gets called, whenever it gets triggered, I then want to instantiate a object. So the object I want to instantiate is the tank shell. The position of this is going to be based off the projectile origin. So I need to use get position. because that is a transform. So transform get position. Plug that in for the position because this is where I want the object to be created. And then the rotation, I can do the same thing down below here. So I'm going to use transform get rotation. I'll jump out of full screen again. We'll verify this with the script. So we're creating a clone of the rigid body. So this is going to instantiate a tank shell at the origin point of the projectile origin. Same thing with the rotation. And in this case, in script, you would say as a rigid body. And then after that, I then want to apply a force to that. So I need to, let's see. I want to, let's see. How am I going to approach this? Well, before we actually apply a force, let's just make sure that this works. So I'll leave the shell force as is right now. I'll create a group for this. And this will be the tank shell. Okay, this will only be called if I press fire 1 and we've met the fire rate requirements. So we're going to go through the recoil back and then shoot out a projectile. So we have the shell assigned. We have everything else assigned here. We're not using shell force quite yet, but we just want to make sure that this actually instantiates at the position and rotation that we want. Okay, so there we go. Now let's see if I rotate. Okay, so no force is being applied to the shells. So they just fall directly in front of us. But you can see it's matching the rotation of the barrel, so it'll accurately shoot in the direction that the barrel is pointing in. Now what we could do, instead of actually applying a force through here, is we can apply a constant force component to the tank shell. So when it first gets created, we can then apply force along a specific axis of that tank shell. So I'm going to try that out. It's going to be a little bit easier than trying to do it through the visual scripting. So I'm going to go back to the prefab of the tank shell. It has a rigid body and a capsule collider. And I want to rotate this. Let's see, let's go back up here to local. I want to apply a force along the local z-axis. Okay, so I'm going to add a constant force component to this. And we have a 2D version and a 3D version. And I'm going to apply a force along the z-axis. So I'm going to use the relative force. And I'll type in 30 for the z-axis. And let me just make sure. Yep, okay, that's it. Okay, let's give this another quick try. Okay, so it looks like it's floating downward a bit. I think it's because the gravity is overpowering it. So let's go back into the tank shell. I'm going to bring this up quite a bit. Let's bring this up to 100. And I think I'll keep this open up on the side here. Okay, a little bit better. It still kind of feels floaty a bit. So let's crank this up to say 500. And yeah, I think that's fine right there. Jump back into the scene, make sure that the barrel is actually moving forward and backward. And it looks like it's shooting just slightly above the barrel, so I need to reposition that object so it's a little bit closer to the center point of the barrel. So I'll move it down a bit, and I think, let me drag in the tank shell, make sure it actually isn't too big for the barrel. Probably bring it down just a bit. Let's go down to 1.45. .35. Just so it doesn't look like it's getting stuck inside the barrel. And then I'm going to update this. Now with it having a constant force like that, if it does hit an object, it's actually going to be bouncing around and still flying through the air. That's something we can take a look at later on. But what we can do for now is just implement a feature where it actually destroys itself if it does actually hit an object, whatever object that is. So we'll add that in as the last thing that we'll cover for now. So I'm going to create a macro for the tank shell itself. And we don't need any variables for this, but I do need a macro. And I will call this projectile. Okay, I don't need start or update. All I need to check to see is if we have a collision. So I'm going to add in a on collision enter. And whenever I hit anything, I then want to destroy this game object. So let's add a unit. Destroy game object. Maybe it doesn't like that wording. I'll just go with destroy. And I'm looking to destroy the game object instantly. And then the object I want to destroy, I think we can go with this. Self. Yep. So destroy itself whenever we hit anything. And I'll just say projectile impact controls impact destroy of the projectile. Okay, let's give this another quick test. Let's see if these actually destroy whenever they hit something. So I'm going to be shooting this little container right here, and let's see if they destroy themselves. Okay, it does destroy itself. It looks like it's going through it, but it's not. It's actually destroying itself. Okay. So I think that's where I'm going to stop for now. We have the basics of our tank. I can move the turret around, I can fire, I can move the tank itself forward and backward and also turn in place. Let's actually take a look at what we have so far. I'm going to close up this graph and we're going to go into a full screen view here. And let's actually move the camera up a bit. That's what I did in the other scene. So the turret empty has a camera. Move this up and rotate it downward. And maybe move it in a little bit closer. Okay, so if I want to shoot that, I'll probably refine the projectile shooting in the next stream. But now we have all the basics set up, so I can move, I can turn, and you can see the turret rotates independently. I'll probably also increase the speed of the recoil, but those are all minor things we can tweak later on. Okay, so I think I'm about done with this tank for now. If there's anything that you guys would like to see involved with this tank, do let me know. I would like to make this into a series. What I have planned for future live streams with this tank is to introduce UI stuff like a crosshair, maybe some sort of health value, something of that sort, something displayed on screen letting us know how this tank is doing, and also have things like if you've ever played Battlefield 5, they have a mechanic where you can repair tanks, so introducing health, and also have like a UI indicator on screen letting you know how far you are along in terms of repairing that tank, and also display the amount of health that tank has, things of that sort. I would also like to go over adding in visual effects like the muzzle flash, or I guess the turret flash. So whenever I fire, we have this big plume of smoke and fire coming out of it. And also if we take damage, have things like smoke and fire, or even sparks come out from the side here. Things of that sort. So that's what I have planned. If you have something else in mind that you would like to see with this tank, please do let me know. And if there's anything else that you would like to see change with this series, if you like more of the visual scripting, if you want to keep it the way it is, if you want more of the traditional C# scripting, let me know. Again, I want to be able to cater to you guys so you guys can follow along and enjoy this series. Making games is harder than making movies. Yes, indeed. I've never made movies before, but I'm sure they're hard as well. But games are definitely one of those things that are, it's like creating a movie, but you can control stuff in it. So you have to be smart about how things are being controlled. And you always have to account for things that you don't want happening in your game. You can't really do that with movies. Okay, guys, I'm going to stick around in the chat for a couple minutes after the stream. I'm going to go ahead and end this here, and I will have this uploaded in the future. Part 2 is not going to be uploaded because it did have some issues with the connection, and it wasn't a very good quality video overall, so I left that out. But I'm going to upload this one and any subsequent live streams that we have in the future. So thank you for joining me in this live stream. I really appreciate everyone being here and learning more about game development. Again, if you have any other questions on anything we've covered today or anything game development wise, please do let me know in the chat and I'll do my best to answer your questions. So until next time, thank you for joining me.